Gillespie here. And in the last problem, you learned how to evaluate functions. So we have this special function, f of x, and when you find out that x is an independent variable, and I could scroll up to another problem where we did have, it's probably tough to notice here, but in the problem previous, yeah, it's easy to see, hey, x is an independent variable, and when y is the dependent variable, well, you have this special function. It's called f of x. And when you have the dependent variable dependent on the independent variable, or another way of saying it, when x is the dependent variable and y depends on x, then you write it in a special function that is called function notation. Function notation is stating f of x equals x, and that is written up here. F of x equals x. So actually, I didn't write it out all the way. So f of x equals x. Well, f of x equaling x, that is called function notation. And you're basically saying, hey, my dependent variable depends on my independent variable. So moving forward from here, let's actually look at another scenario where, we've been talking about f of x a lot, but that's not the only way that you have to write function notation. You can also write it using other variables or letters, and I could say, hey, instead of f, let's write, oh, I don't know, I'd put g down, g of x. Well, g of x is the same thing as saying f of x. I haven't changed anything. I just used f as my variable first. And in fact, x does not have to be the variable inside parentheses. In some cases, you're going to find that, hey, some people are going to use, z of b, or z of t. It doesn't matter what is written in the function rule because they are both variables and they represent various numbers. Therefore, just keep that in mind when you're coming to situations, whereas g of x would still equal f of x, which could equal z of b. It doesn't matter. Don't let that confuse you when you come across problems. But let's look at a scenario where we're going to find reasonable domain and range of a function. Okay, so I'm going to just give us some space here. And I'm going to find, let me get something written up for us. Cool, so I'm going to pull out my typewriter here, and we'll just type something up. Let's say that Jacob has already spent $36 on tickets for German lessons. And there are 3 more lessons that he can take. And each lesson costs $4.50. So write a function rule to describe the total amount of money, I should say the total amount of money that Jacob might spend on tickets. And then give the domain and range for the function. Cool. So all that a function rule really is, it's an algebraic expression that defines a function. I'm just spreading this out some. And all that a function is, it's a special type of relation that pairs each domain value with exactly one range value, or for every or each x, it only has one y value to be a function. Cool. So let me get my pen back out here. And that's my phone going off. All right, so getting that pen out still. So let's write a function rule. And all that a function rule is, it's writing an algebraic expression that defines the function. So to create the function rule, let's go through, I'm going to choose a good color here. Let's go through and actually select what the dependent and independent variables are. Well, the independent variable, it's going to be a couple parts here. One, it's $36. You know that, well, Jacob has spent $36. And also, it's going to be the cost of any additional lesson here. So it would be 450 plus times the possible amount of lessons. You know there are 3 more lessons. So also, you need to find the dependent variable. And the dependent variable, it depends on the independent variable. Well, that is, the total amount is going to be the dependent variable. And the total amount that Jacob, here's a key word here, guys. The key word, let's choose a whole new color here. The key word is might spend. Now it's saying, hey, Jacob might spend the money, but it's not necessarily that he is going to. But now I can actually write my function rule here, and I'm going to just put dependent on this side. And what this is telling me is, hey, my dependent variable is going to be f of x, or the cost that Jacob might spend, the total amount. And I'm just going to box all of this up here. Well, I didn't want to do that, so let's just make, actually, I'm going to change my tool in a second. Cool. So I got one box here, then I'm going to create a second box right here. And inside the second one, yeah, you guessed it, I'm going to write independent. And it's going to be the, well, it's going to be, one, the cost of tickets. Well, the cost of tickets, or how much Jacob spends, is going to be 450 times x. And he's already spent $36, so the total cost will equal 450 times x plus the $36 that he's already spent. Fix that line up just a little bit here. There we go. So that's just separating, just letting you know, f of x, it's going to be the total. Well, f of x, guys, actually equals 450 times x plus 36. So let's just do a good old equal sign here. Didn't come out as well as I thought, so let's see if I can change this up some. And just separate this out. Cool. Yes. So the dependent variable, like we said earlier, it equals the independent variable. That's our function rule. So now let's go ahead and start creating some tables and really parsing this information up here, parsing that up there into more legible or just more structured information, something that you can really understand. So I'm going to create a box here, and within it, just divide it in half. And I'm going to create, basically what I'm saying here is, hey, these are my domain and my range. Oh, that's real sloppy. That's not going to work. Get a new color. Well, you got your domain. I'm going to try it one more time. I'm not seeing my color pop up the way that I want. Let's do this. Got the domain and got the range. So I'm going to write these up. First, I'm going to write down my domain because those are pretty easy to spot out. And the domain are going to be my x values. Well, that's going to be, well, it looks like there are 3 lessons that Jacob, the keyword was might take. So he's not going to actually spend all of his money at once because he might not even take any lessons. So therefore, the domain could be 0, 1, 2, or 3. He could do any of these, make any of these choices, and our goal is to find out what the dependent variable or the total cost would be based off of which choice Jacob chooses. Now, let's go ahead and write out another table. I'm going to create a second table here. This table is going to be a little bit larger because I'm going to put some more information in it. And I'm going to spread it out as much as I can. And within this table, still separated by rows and columns, but I'm going to say, hey, this guy is X up here. So this guy's still my domain. Should probably change my colors again. Stay constant, consistent. This guy's going to be my X. And the guy on bottom will be f of X, which is range and domain still. There we go. And then let's see, what else do I need here? I'm going to say, hey, this top value is when x equals 0 here. I'm just going to go through and separate these out real quick. There we go. All right, so now again, I said the top value is going to be the domain. So I have, again, 0, 1, 2, and 3. And so this would actually be, if I can look back up at my function rule, well, this is going to stand for, well, f of x equaling 450, or I'll just put 4.5 times, and I'm going to plug 0 into there, plus 36. Going back and plugging 0 right into there, and I'm going to change the color on this guy. Put a 0 right in there. And when when x is 0, this is going to equal, well, 4.5 times 0, 0 plus 36. Well, this is just 36. I can go unbox my answer from there. And my first range that I have, my first range value, is 36. Well, let's take a look at my second value here. I was going to plug these back down into their cells down here. Let's take a look at what happens when the x values change here. So I've got x equals 1 and 4.5 times 1 is 4.5 plus 36. Well, that's going to equal 40.5. Box them up. And I'll plug these values up top in a second. So when x is 2, well, 4.5 times 2, well, you have 9 plus 36 is 45. Put a box around that guy, and now when x is 3, you end up with 49.5. Cool. So now it is time to go ahead and plug these values up top in the range. So now I've got 40.5, 45, and 49.5. So if Jacob pays for X more sessions, he'll buy, well, he'll buy f of x equaling 4.5 times x plus $36. And he, in that case, I don't know what the reasoning is. Maybe he doesn't go to a lesson so at all. He doesn't choose to go to any because maybe his instructor smells bad, or maybe he just doesn't like it, or maybe he's just busy. And then maybe if that's the case, he's going to spend $36. But if he decides to go at least 1, 2, 3 more times, maybe he likes the chocolate inside the classroom, or I don't know, maybe the instructor's really cool and plays a guitar or something. But under any of these situations, he'll end up paying more than the $36 he paid up front.